Hey everybody, welcome back. We're going to take a look at lesson 717 today, and that's going to be about the tangent function. So previously we've been using the sine and the cosine ratios to help us find that, but now we're going to take a look at the tangent, which is the last of those things. So let's see what that looks like. All right, so here we go. So Jamal was working on his homework when he had a brilliant realization. He was drawing a triangle in a unit circle to estimate the sine of pi over 10 when he realized that this triangle is the same kind of triangle he draws when he wants to find the slope of a line. How could you expect the slope of the radius in terms of sine and cosine? So just seeing this on a unit circle here. So here's our coordinate and of course our perfect circle there. And then so he's drawing this angle pi over 10 and he's realizing that, hey, this triangle, let me draw this a different color here. This triangle that's being drawn is the same type of triangle that we use when we find slope. We'd say, rise over run. Well, that's that same type of thing that can be used to find the to express that slope in terms of sine and cosine. So here we're going to use sine and cosine to express that rise. Well, that rise, we know that that is the sine of theta because it's a unit circle. So again, it's 1, so it's divided by 1. The run would then be the cosine of theta. So slope here would be sine of theta over cosine of theta. Okay, is there another way you can use a trigonometric ratio to represent slope? Discuss this with your team. So sine over cosine, well, when we're talking about these two edges again, like that's our other function that we've talked about. So that instead of using the hypotenuse, we use the two edges. This is the tangent ratio. So tan of theta would be that piece there. Let's take a look at the next one, 100. Okay, so this one basically is saying this, the tangent function. So just like we've done with our cosine graph and with our sine graph, we're going to do the exact same thing with this and making the graph of it. Then there's some further guidance questions that are in 101 and 102. That's basically what's going to be covered here. So just like we have done before with this graph and with this graph, we're going to go and find all those things and fill out all these values in the charts. But now we're just going to do it for the tangent function, which we know to be that sine of theta divided by that cosine of theta. So a bunch of these numbers you're probably going to recognize as you find that ratio between the sine and between the between the sine and the cosine is just basically what is that ratio that's going to happen between these two things when you divide them. That's going to make the tangent function. So I'm going to try to just cover this real briefly, and I think that you guys will be capable of doing this. But basically, you'll just go and you'll set up on this one. You'll go and you'll find each of those points there. So pi over 6, pi over 3, pi over 4, all those different things, and you'll fill out this table here. And then basically all that you're doing is saying, well, it should be my sine, this number divided by this number, and that's going to give me my tangent ratio, which will be in this purple thing. It should also correlate with what's happening here. You'll have these numbers and just be dividing them. But of course, this is just a little bit off of that there because it's supposed to be 0.25. But you take this number and you divide it by that number, and that should give you your tangent ratio because it's that opposite side divided by that adjacent side to that angle theta, which is happening right there. Once you do all that, you'll see all these dots will appear on the chart. The green one will be the cosine graph. The blue one will be the sine graph. We're used to seeing those. And then the purple one, this is our tangent graph. And see how it kind of looks a little strange here? And then I just wrote all three of the formulas there so that you could kind of see what each of those graphs are doing. But the tangent graph makes this it is almost like an x cubed look, where it's got that kind of like this shape to it. So it's kind of in that family, but it is a repeating graph again that you see. It shows up here again at pi, and keeps going on and does that. So that's everything. I just covered a lot of like what's happening in 100, 101, 102, but I think that'll cover most of it here. So let's take a look at what question 103 is. All right, so let's get into the actual math here. We're starting to use this stuff and not just think about it as a concept. So draw the unit circle. I'm just using this resource page from the last section and label the point that corresponds with a rotation of pi over 6 radians. Well, that is going to be right here, because this would be pi over 12, because there are 12 dashes before I get to 1 pi, which is right there. So here is my angle there. That is pi over 6 radians. What are the coordinates of this point? So I need to know what is my sine of pi over 6. That's going to tell me the y value of that. And I need to know what's the cosine of pi over 6. That's going to tell me the x value. And then I can put those two things together to find that out. But here's the kicker. No calculator. So the unit circle, we generally have a couple of these common values just kind of memorized. It's something that you'll start to get used to seeing a bunch of. So let's see what this looks like. All right, so some of these are just kind of values that you'll start to see and recognize, and probably just actually get to memorize here, because they're not super crazy. There's basically three of them. There's a 1/2, there's a square root of 3 over 2, and there's this square root 2 over 2. Those are basically the three values. And you can see the 1/2 and the 1/2. You can see the square root of 3 and the square root of 3. And you can see the square root of 2 and the square root of 2 there. All those would be over 2. So here in pi over 6, my sine value is going to be equal to 1/2. And my cosine value is going to be equal to square root of 3 over 2. And that's because this number, the square root of 3 over 2, is the longer side. It's longer distance than this height here is. And square root of 3 over 2 is larger than that. If you want to think about it like this is kind of how my brain does it too. When I think about 1/2, well, the sine then means that I've got to have this kind of opposite over the hypotenuse. So my opposite would be 1, my hypotenuse would be 2. And so then if my hypotenuse there is 2, which I know is a little bit confusing because we're talking about a unit circle, but it's just easier to pop that up to 2 because the math just works out a little bit easier. So here, if I pop it up to 2 and think about Pythagorean theorem here, I should have 2 squared, not 4. 2 squared should be 4. So I need these two side lengths squared to get me to 4. Okay, well, that's got to be that 1 squared and that 3 squared. 1 and 3 squared added together should make 4. And so these two, and then same concept holds true on this angle. The square root of 2 and square root of 2 squared, that's 2 and 2, that makes 4 again. Again, we're getting back to that. So that's kind of where these numbers come from, is just saying, hey, where just this top number and this top number need to get together to make 4, because I'm dividing, but then I'm dividing that by 2, which is how I'm getting back down to that unit circle of 1. So just those are not just like random numbers, but there's actually some sort of logic there that's based off of Pythagorean theorem here. So we're basically going to use these three numbers, and we'll be able to figure out each of the different sizes that we have listed here. So that is what's happening there. So the exact value, just to give the bow on it here, would be this. My sine was 1/2. That's the y value. My x is square root of 3 over 2. So those are the exact coordinates. Let me clear off some space, and then we'll come back and we'll take a look at the at part B, letter I. All right, so we're going to use this to find each of the values without a calculator. Hint, drawing each angle on the unit circle will be helpful. So we'll start off with pi over 6 radians. Well, 6 over 6 would be 180. So I just need to go one more sixth. Hint, hint, this is going to be a pretty similar triangle because it's just one of the other inversions of it, so to speak, as our first one. It's just down in, now I'm in the negative side in the x value, and I'm in the negative side in the y value. So this is the same angle, but it's just in the negative side. So now I need to go down by 1/2, and I need to go backwards by square root of 3 over 2. So if I'm talking about the tangent of that stuff, well, the tangent is just sine over cosine. So I'd have negative that over negative that. So then from there, we're new, much like we did in the previous problems, where we're going to simplify that. So I've got negative 1/2 divided by square root of 3. That's a negative over 2. And we can do our flip the fractions and multiply them. And I'm just going to dump the negatives because negative times by a negative is a positive. So that will clear that out. And I've got that. And then my 2's will cancel. And what I'm left with is just 1 over square root of 3. So tangent here should just be 1 over square root of 3. This is also, again, to clear the radical sign down below, it's also written as square root of 3 over 3 as your answer there. Okay, so that would be my first one. My second one here, I'm going to do the cosine of 13 pi over 6. Well, hey, 13 pi over 6, let's break that down. Well, 6 over 6 would be 180. Another 6 over 6, so 12 over 6 would be 360. And then 13, well, that's just one more. Hey, this is the exact same angle. Let me do a different color here for this one. So this will be the exact same angle that I'm doing there. So guess what? We've already found this one. We already know what the cosine of 13 pi over 6 is. That has to be square root 3 over 2 because it's the same value as what I had for the coordinates there. Last one, I'm going to do this one in red. Tangent of 2 pi over 3. Okay, so 2/3, that's the same thing as 8 over 12. And I'm just using 12 because my unit circle here is already split into 12. So I would have 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be my angle now of what I'm looking for in theta. Let me clear some space. Okay, so we're in the second quadrant. So I know that my cosine is going to be negative, my sine is going to be positive, but I'm just going to always compare it back to my first quadrant here. So this angle right here is going to end up being 60 degrees because 2/3 out of 180, again, 2/3 pi, that'd be 120, which means I have 60 degrees left out of that 180. This is where the 60 comes from. So I'm going to compare it to my 60-degree angle. Sorry about that. 60-degree angle back here, which is my pi over 3 angle. So pi over 3 would be my 60-degree angle in the first quadrant here. So that means that my sine value is going to be that inverse. It's going to be that opposite one. Not opposite, not inverse, but just the other value there. So it's going to be the kind of changed form of our 30-degree angle there. So same thing here, but recognize that my cosine is going to be negative. So my cosine of this is going to be negative 1/2 because I'm moving backwards in the y or in the x-axis, and then I'm moving up in the y. So this is still going to be a positive value. So that is going to end up being that same square root 3 over 2. But now I just need the tangent of that. So that's sine over cosine. So I'm going to end up with a negative number because positive divided by negative is a negative. I'm going to have negative square root 3 over 2 divided by that negative. So I should not have done that negative out front, but I just wanted to not have to deal with it. So this value is actually a negative 1/2, but I already accounted for it out front here. So just ignore that here. So divided by 1/2. So when I do that, I am going to flip my fraction and multiply. My 2's will cancel. I'll just end up with negative square root of 3 as my final answer there. Okay, that's a whole bunch of everything for this section. Let me know if you have any questions. I'll see you next time.